The question we are solving now belongs to test series 10. It is of control system subject. In specific, it belongs to root locus of the control systems. As per the question, the open loop transfer function of a unity negative feedback control system is given as k by s multiplied by s plus 3 multiplied by s square plus 3s plus 6. There are three statements given as related to the root locus of this control systems. The statements are: on real axis, root locus exists between minus 3 and 0 only. Intersection of the asymptotes on real axis is minus 1.5 and root locus ends at minus 3 only. We need to pick the correct statements out of these. We know that the root locus starts from open loop poles and ends at open loop zeros. From this, we can say that the root locus starts from 0, minus 3 and the roots of s square plus 3s plus 6 equal to 0. From this, but as per statement 3, it's given that root locus ends at minus 3 only. Hence, the statement 3 is not correct. And also we know that, and upon finding the roots of s square plus 3s plus equal to 3s plus 6 equal to 0, we see that the roots can be written as minus 3 plus or minus 9 minus 20 square root of 9 minus 24 divided by 2, that is equal to minus 3 plus or minus root 15j divided by 2. And now if we find the existence of the root locus on real axis, we can say that root locus exists on real axis at a point A if and only if the number of poles and zeros to the open loop poles and zeros to the right of that section is odd. And if we consider the range minus 3 to 0, we see that in this range at any point the number of open loop poles and zeros to the right of section is either 1 or 3. Hence we can say that root locus exists between minus 3 and minus 0 only on real axis, and it doesn't exist in the range of minus infinity to minus 3. This is due to the reason that in this range the number of open loop poles and zeros to the right of any point is even. Hence the statement 1 is correct. Now let us find the intersection of the asymptotes on real axis, which can be written as sigma p minus sigma z divided by np minus nz. So this can be simplified as minus 6 minus 0 divided by 4 minus 0. Upon simplifying this, we see that the intersection point is minus 1.5, hence the statement 2 is correct. From this data, we can see that out of the three given statements, only statements 1 and 2 are correct. Hence the correct option is A. This is the correct option as related to the root locus of